So a big part of AP Chemistry Unit 3 is going to be intermolecular forces. So let's start by defining what those are. So when we think of a water molecule, H2O, we tend to think of the forces holding that molecule together as being related to these covalent bonds right here. But these are intramolecular forces. These are forces that are within the molecule itself. But if we think about ice, an ice cube melting into water, the temperature is not breaking these covalent bonds. It's still water. It's not hydrogen and oxygen now. It's just water, but it's not held together quite as well. So this is where intermolecular forces come in. So this is how strong the forces are between water molecules. So if there's a water molecule here, and then another one over here, then it's going to be how strong that connection is. So to examine this, we'll start by looking at the different types of intermolecular forces. So we can start with dipole-dipole forces. So if we remember from the last unit, we learned about polarity. So that basically shows that if we have an H2O molecule here, there's going to be a partial negative dipole towards oxygen due to the electronegativity difference. And then a partial positive dipole near the hydrogens for the same reason. So if we had a lot of water molecules near each other, they'd be held together by dipole-dipole forces. And so if we had an oxygen, hydrogen, hydrogen, then the negative dipole up here due to the oxygen is going to be attracted to the positive dipole of another water molecule. So if we had hydrogen, oxygen, hydrogen, then the positive dipole from this hydrogen is going to attract the negative dipole from the oxygen in the other water molecule. And this is due to Coulomb's law, because the difference in charges. So what this does is it holds the water molecules closer together. And these forces are harder to overcome the stronger they are. And that means it would take more temperature to melt or boil them. So the next type of intermolecular force that we'll examine is an ion dipole force. So imagine that we had sodium chloride dissociated in water. So we'd have Na plus ions and then Cl minus ions just floating around in the water. And because these are positive and negative charges, they're going to attract the dipoles from the water molecules. So if we have Na plus, that's going to attract the O's, the oxygens. So we have oxygen here, hydrogen, hydrogen, oxygen, hydrogen, hydrogen. So the negative dipoles from oxygen are going to be attracted to the positive charge on the sodium. And the same goes for the negative chlorine. The positive hydrogens are going to be attracted to the negative chlorine. So here are some examples. So this is also going to increase the amount of intermolecular forces and the strength of them. So instead of just dipole-dipole forces, there are also ion dipole forces. Then the next type of intermolecular force that we'll look at, which is actually the strongest one, is hydrogen bonding. So this occurs when we either have an HN bond, an HO bond, or an HF bond, not H to C. This is not considered a hydrogen bond. So whenever you have one of these bonds, that's going to be it's going to have very strong intermolecular forces. So if an AP question is asking you which molecules have the highest intermolecular forces or the highest boiling points, then the first thing you want to look for is the hydrogen bonding. But then again, if it asks you to list all of the intermolecular forces involved, the most important thing that you're going to have to list is London dispersion forces. Okay, so what are London dispersion forces? This happens when we have, let's say this is our nucleus, and the nucleus is surrounded by a cloud of electrons, right? So the electron has a different probability of being at each point around the nucleus. So this is called a cloud of electrons. And what can happen in this cloud of electrons is that occasionally if we have another one here, occasionally more electrons can end up on this side than on this side. And what this leads to is a partial negative charge on one side of the atom. Even though the atom is overall neutral, one side can spontaneously become negative, partially negative, just due to probability. And the bigger the electron cloud is, the more likely this is to happen because there are more electrons. And so what this does, if there's another electron cloud over here, there are fewer electrons on this side, so this is a positive dipole. This is going to attract electrons from here, and then we'll have fewer electrons over here, and then a lot of electrons over here. And then this force between these two is called a London dispersion force. And the bigger the electron cloud is, the stronger this is going to be, just because there is a higher probability that more electrons are going to be on one side than the other. So whenever an AP question asks you to list the types of forces that are involved in a certain molecule, LDF, London dispersion forces, are always going to be there, no matter what. No matter what the molecule is, always list London dispersion forces. The other ones are dependent on the case, but always remember London dispersion forces. This one is very important. So now the final type of intermolecular force that we're going to examine for now is called an induced dipole. An induced dipole force. So this happens when, let's say we have a neutral atom. So let's say this atom has a charge of +6 in the nucleus, then it has 3 electrons over here and 3 electrons over here. So the -6 and the +6 cancel, and this is a neutral atom. But now let's say we had, a sodium ion over here, a positive ion that's dissociated in whatever molecular compound this is. Then this positive charge over here is going to cause some of these electrons to be attracted to the sodium. So then that could cause this same atom with +6 charge in the middle to have 1, 2, 3, 4 electrons over here and only 2 on the left. So then there are going to be a few more electrons on one side than the other, and that's going to induce a dipole, a negative dipole on this side and a positive one on this side. And then that's going to hold these together a little bit more. So while this is not as strong as a dipole-dipole intermolecular force, this can still happen temporarily between neutral molecules or atoms, which can still sometimes be significant. So to summarize what we have so far for this part of the unit, we have dipole forces, which are between partial negative, so partial negative to partial positive. We have ion dipole forces, which are between a dipole and the plus or minus charge with an ion. And then we talked about hydrogen bonding. So remember, this occurs between when there's an HN, HO, or an HF bond. And then there's London dispersion forces, which occur when there's a larger electron cloud, which usually happens when the molar mass is increased, / molar mass. That's usually when these forces get stronger. And then lastly, there's the induced dipole force, which usually occurs between neutral and charge, plus or minus. So these are the different types of intermolecular forces. I hope this was able to help you start AP Chemistry Unit 3. And let me know how I can make these videos a little bit better so you can help you understand the content a little better. And thanks for watching. Tune into my next video if you can.